It's not an hour, so go back to dance. More. That's only 5 minutes. Okay. Anyway, so yeah, so we'll have class Monday through Thursday. So it'll be 4 days a week. I'll still do the same thing where we try to finish everything in class. And also, I really appreciate you guys being here. I know that not everybody's here. I'm not sure why, but we do have the recordings for everybody, but it's better live, hopefully. So today, I really want to encourage you to unmute yourself and ask questions. I'm going to do a quick review. So if you want to get paper handy, and then we'll do a little bit. So basically, I'm going to review all of this stuff in a quick way. So we've done like 3 weeks worth of stuff. Let's review it all so that we have it in our mind. But I do want to encourage you guys to participate. So ask questions, just talk. So today is going to be number 17. Number 17 review. And we'll start and then start factoring. And factoring is, let me just do something real quick. Factoring is kind of the reverse of multiplying, like riding the bicycle backwards. Let's see, what was I going to do here? Get this one off. There we go. Okay, so let's just review functions, and which is kind of cool. You guys have come a long way from when we started. This is the name. Let me make sure we're good. This is the input letter variable. And this is what it does. Okay. All right, so let's do a function. Let's put it in this form. 2x minus 3 twins. And that's like yesterday. And there's a reason why I'm calling it twins, because later on we're going to make twins. All right, guys. So if you can participate here, what form is this in? Is it in standard form, factored form, or vertex form? Anybody?
Factored.
Factored. Okay. Anybody agree, disagree? What can you get from this function just by looking at it? Actually, you know what? Let's change that last 3 to a 4, just so that. Go ahead and just change it to a 4, just so that we don't confuse the 3s. Anybody agree, disagree with that this is in factored form versus standard form? Or
I agree.
You agree? Okay. Anybody disagree? All right. Some of you might have your notes nearby. And let's see. What number can I slide into the x to make that -3 disappear? To make it become +3. So then you put if x equals 3, then you're going to have 2 times 3 minus 3, right? Twins plus 4. This is going to become 2 times 0, twins. This becomes 0 plus 4. So y is 4. when x equals 3. So this point right here, is it the vertex or is it the x-intercept? Is it the vertex or is it the x-intercept? By the way, can it be an x-intercept if it doesn't have a 0 on the y? Is that possible? No. Okay. So this is actually the vertex. 3, 4. 3, 4. All right. So I kind of gave it away. So what form is this function in? Factored, vertex, or standard? Which one? What form is it? What is given? What information?
Vertex.
Vertex. Yeah, this is the vertex form. Okay. All right. Next, the next thing that was just a review. These are the steps. The height of the steps, right? And the height of the steps are 1, 3, 5, 7 times 2, right? Times 2, times 2, times 2, times 2, times 2. So the first step is 2, the next step is 6, the next step is 10, the next step is 14. All right, so we have our steps here. I'm going to go up 2 over 1, and then up 6 over 1. Just pretend that was 6. All right, and then I got my steps. Now you could also plug in numbers and get the same. Pretend that's a 6, right? That's not obviously not a 6. And there's your function. There's your function right there. And the reason I wanted to do a review was because we took a week off break, and learning is like that. You kind of forget stuff, but you need to review it. All right. So there's my vertex graph. And notice how I drew it without doing a lot of math. By the way, this right here is not even necessary if you knew that 3 would cancel everything except the 4. You guys agree with that? All right. So that's the review of vertex form. I'm going to start the factored form next. But any questions on vertex form?
You know what you should?
Any questions on vertex form first? All right. Let's review factored form. Okay. I'm going to try to make my colors really good. All right, here's factored form. I'm going to call it G. I'm going to give it a negative 2 x minus 3 x plus 3. And notice that these are like yesterday's. Are these identical twins or fraternal twins? Remember yesterday?
Fraternal twins.
They're fraternal twins. So you're like, cool, they're almost twins, right? So we'll call these fraternal twins. Fraternal. Now that's made up by me, right? So these are fraternal twins, and this is factored form. So let's not do any math. Let's just understand math. All right, here we go. Here's my graph. I should make it a little lower. Let me erase this guy right there. All right, let's make this a little lower. Notice I'm trying to draw a little better than normal. Okay, all right. So let's see. What x value can you slide into here that's going to cancel that negative 3? what number can you slide into x that's going to cancel that?
Positive 3?
Positive 3. So 3 goes in there. I wanted to put it in red, pink, whatever. So if x equals 3, so if you say, oh, if x equals 3, I'm going to have negative 2 times 3 minus 3, 3 plus 3. That should have been pink. All right. So then we have negative 2 times 0 times 6. And what's 0 times anything? So y equals 0 if x equals 3. So that is a coordinate, 3 comma 0. And this is an x-intercept because the y is 0. So that's going to be 3, 0. All right. And then conversely, if you put an x here, what x will cause that positive 3 to disappear? What x would negative 3? Now, I want you to check this out. Look at this. Fraternal twins, they are the same distance away from the y-axis. You see that? So fraternal twins, they're like, well, they're just opposite of the y-axis. Okay. Therefore, the vertex is going to be right in the middle of them, which is x equals 0 is axis of symmetry, right? That's the middle, right? That's the middle of it. So I'm going to do the axis of symmetry. Actually, we were doing yellow back in the day, or orange. I'm going to do it just kind of slightly off of the, just so you can see it. All right, so now we're going to plug in 0 to the equation. All right, so let's plug in 0. So we're going to have negative 2 times, I'm going to plug in 0 for x. I'm going to keep my same color. So then I'm going to have negative 2 times negative 3 times positive 3. Oh, darn it. I didn't graph this high. I didn't graph this. This is going to be way on the top. Okay, so what number is this going to become? 18. So that means if x equals 0, y equals 18. So that's my vertex. Now, I guess I could go by 2's, right? 2, that's only going to be 10, 2, 4. Yeah, I'm not going to get up there. I'm just going to make it up. Just pretend that this was 18. Okay. All right. By the way, what size are the steps from the vertex?
Two, six, like it's 1357 times 2.
Yeah, and good job. And don't forget, Amar, it's negative 2. So it's so it's going down. Okay, so you can go down 2, right? And pretend these are by 2's. So then we're gonna go down 6. So it's gonna be 3 of these. 1, 2, 3, and then 5. Remember, I made these by 2's. So it looks like the same as the other one, except they're going to be taller, right? These steps are double, and also going down. The steps are going down instead of up. Okay. All right. So this is in factored form. Oh, I forgot to write that. This is a factored, and it's ed, which means it got done. like what's a word that ends in ed that's a verb? Tired. I got tired, which means I did something to get tired. What's another word that ends with ed?
Fixed.
Fixed. Yeah, thank you. It fixed. This guy fixed, which means it used to be broken. Now it's fixed. So this got factored. And that's the hard part of algebra is factoring. Okay. And the first one was called vertex form. All right. So anybody have any questions on factored functions? So factored give you the x-intercepts easily, right? These are easy. And then from there you gotta find the middle of them, and then you're gonna find the vertex. Okay. And then you can do the steps, right, from the vertex. All right. The last function, remember I was making an analogy of the three functions of my cartoon that I used to watch as a kid, Robotech, that had three different forms. They had the airplane that converts into a robot and converts into a half robot, half airplane. All right, here's the last one. I'm going to call this h of x. And this one is going to be, let's call this half times, oops, in standard form, there is no parentheses. All right, this is standard form. And standard is in my opinion, the hardest one, because you can't find the vertex really easy, and you can't find the x-intercepts either easily. All you can find out is the what do you guys think you could find out easily? If you can't find the x-intercepts or y-intercept, what could you find out easily? What do you guys think? So x-intercepts, nope, not easy. Vertex, nope, not easy either. What about the y-intercept? What x is right here? What's the x value there? What is this coordinate? How's that? That's 0, 1. What's this coordinate right here? 0, 2. What's this coordinate right there? 0, -2. So we do know the x, and that is 0. So x equals 0 for y-intercept. All right, so let's plug in 0 for the x's. I'm doing it in purple. So plug in 0 there and there. So what do you get? Okay, I know I'm doing a lot of work, but it's all good. Get the idea. 0 times half is 0, and then -4 times 0 is 0, and then plus 2. So what is the y-intercept? The y-intercept is 2. So I'm going to use purple for that one. Right there, that's my y-intercept. All right. And in standard form, that's all you really can get easily right now. And I'll show you guys later how to get the the other stuff. So for this one, you would have to make a table and just plug in and keep on plugging in and plugging in and plugging in. All right, let's plug in some numbers then. Okay. All right, so we already done 0. What number would you like to plug in? 1 or -1?
1.
1. All right, let's plug in 1. There we go. So I'm going to plug in 1. I'm going to erase a little bit. I'm going to cheat a little bit, if that's okay with you guys. I'm just going to change this. Oops. I try to cheat too much. I'm going to just plug in 1 right there. All right. So what's half times 1? Half. And what's 4? -4 times 1? -4. Just gotta get my pencil back. There we go. So I'm going to plug in 1. Plug in 1. All right. So this is going to be half. And then -4. All right. So what's half plus 2 minus 4? Think of money. I'm going to add the $2 plus the half is 2.5 minus 4 is -1.5. So that would be my y right here, -1.5. So this was we said this was 2. We got that. And then if you plug in 1, we said -1.5. -1. All right. 1. Yep. Wow. Okay. So that's going to be down here. All right. So far the graph's starting to look like it's going down like that, right? Make sense? Now we don't know if it's going to keep going down or if it's going to start turning up. So would you like to plug in -1 or 2? What do you think?
Let's go 2.
Let's go 2. Yeah, I would go 2 because look, this one, the graph, you can already tell it's going up here, right? So I want to see if it's going to go this way, if it's going to go this way. Does that make sense? It's going to be the, see the idea? So let's plug in 2. Yeah. So let me just erase my, okay, right there. Okay, so plug in 2. So I'm going to put 2 here, 2 there. All right, what's double of half? 1, right? And double of -4 is -8. So we're going to have 1 minus 8 plus 2. I like to join the 1 and 2. That's 3. So it's going to be -5. So 2, -5. So it looks like it's still going what? Still going down. Now, we don't know if it's going to start picking up. It's going to keep on. Does that make sense? We still don't know, right? All right, so let's try 3 now. 3. All right, 3. I'm sorry if I'm going to get a little messy here, but I don't want to write the whole equation again. All right, this is going to be -12, right? And 3 times half is 1.5. All right, so we got $1.50 plus $2. That's $3.50. And 350 minus 12 is 8.5. Look, it's still going down. 3, 8.5. It's still going down. Man, I wonder when this thing's going to start turning. All right, now we got to plug in 4. All right, 4. I'm going to use some other color. All right, what's 4 sets of half? 2. Okay, I know this is messy, but and what's -4 times 3? I'm sorry. It's supposed to be a 4 now. So it'd be -16. Okay, so that's going to be 4. 2 plus 2 is 4. That's going to be -12. Man, this thing is still going down. Wow. All right. So anyway, you get the idea. Like we still don't even know when it's going to start turning. We don't know. So we got to keep on plugging in. So that's why I want to show you that it's kind of like, well, it's got to be a better way than this, right? This has to be a better way, okay? And of course, you can go to Desmos and type it, and you'll know it instantly, right? That's not the point. Okay, so and I'm not going to show you just yet how to find the vertex. So does anybody want to know how to find this a lot easier right now? Anybody curious? Like
You said find it easier?
yeah, this. I mean, like this is really like tedious, right? Yeah. Does anybody want to know how to find the vertex really fast?
Yes, please.
Yeah, because that's all I want is the vertex. Once I know the vertex, man, I'm done. Like I can just. All right, here's what you do. Ready? And we'll cover this in depth a lot. This. All right. You get the opposite of the second number. What's the opposite of -4? 4, right? And then you divide it by double of the first number. I'm going to call that A, and I'm going to call the second number B. And by the way, I didn't actually come up with that. That's what all people do. So what is the opposite of B? What's the opposite of -4? 4. Now we're going to divide it by double of A. What's double of half? What's double of half? So what's double of 50 cents? 1. So that's going to be 4 divided by 1. It's 4. That is where the vertex is going to be at. And we already found it right where. That's the vertex. That's going to be the lowest. So we actually found the lowest. And then from there on, it's going to start going up. It's going to start what?
So can you just do like the opposite of -4? Why do you have to divide?
Oh, so good question. So the thing is, and let me show you with Desmos, just so you can see that. I'll check this out. All right, let's do x squared plus x plus 1. Put -1. Okay, and then I'm going to put a letter here, A. Oh, actually, it's supposed to be B, right? B, and then we'll put A here. All right, and check this out. Now, keep an eye on the graph. I'm going to move the B. I'm going to make it to the right. And you tell me which way the graph goes. Is it going to the right or to the left?
It's going to the left.
Exactly. See? And if I go to the left, which way is it going?
To the right.
There we go. So we have to say the opposite. So if you want to know the vertex, it's the opposite way of where it's going. Okay? All right, so let me just put it as a +1. I'll put a 3. All right, now A is the steps. Remember the size of the steps? If I make it bigger, the graph starts to stretch, and the vertex starts to move too. See that? Now I want to know, if you want to keep an eye on the actual vertex, it starts to move, right? So the formula, and this comes from calculus, by the way. The x of vertex, this is the x only, is that. And you want to write this in English, and it's the opposite of B divided by double of A. Okay. And if there is no number in front of x squared, that's a 1. So this comes from, this is the only formula you'll need to find the x of vertex. Okay. All right, so let's try it with another one, okay? Here we go.
So, I don't know if I missed something, but what do the A and B stand for?
Oh, good job. Here. So, in standard form, A is the variable of the letter in front of x squared. So if there's no number there, it's a 1, right? So there might be a number in front of A, like 2, the steps. Remember the steps get bigger? 3, 4, 5, 6, right? So B is the letter, the number in front of X. If there is no number in front of X, it's a 1. But it might be a 2, it might be a 3, right? And then C is the last number, but we don't need it for this particular formula, right? So now this only works on standard form, right? The standard form doesn't have any parentheses, okay? Good questions, guys. So let's try one, right? All right, let's do an equation. Y, let me stick with black here. Y equals x squared minus 4x plus 16. All right, so let's just write down. What number is A? It's right in front of x squared. And remember, if there is not a number there, by default, what number is it? 1, okay? And B would be this number. And it's not 4, it's -4. Make sense? All right. So let's find the x of vertex. X of vertex. Because you don't want to be plugging in numbers over and over and over, just trying to find the vertex. Like we were doing earlier, it's just kind of a waste of time, right? We're just like trying to find it, right? It's like it's almost like trying to find something in your closet in the dark, right? It's not efficient. All right, so let's say the x of vertex, the opposite of B divided by double of A. So what's the opposite of -4? So it'd be 4, right? And then double of 1. What's double of 1? 2, right? 2 times 1. So what's 4 divided by 2? 2. This is the winner. This is gold. This is gold mine. Nice. This is you turning on the light in your closet trying to find something. So now we can find the vertex. Plug in 2. Right? So we're going to plug in 2 because that's the x of the vertex. All right, so let's plug in 2 for x. I'm going to put in parentheses. And the reason I like to put in parentheses is because it might be negatives. The negatives will always throw me off unless I put them in parentheses. All right, so let's go. 2 squared is 4. This will be -8, and then it's plus 6. All right, so what is this? What does this add up to? So what is this? What is 4 minus 8 plus 6?
2.
2. Now, it's just coincidence that it's also 2, okay? Is y, right? Pure coincidence. So that's my vertex, 2, 2. Okay. Now, I wish it came out to a different number, but okay. Now, let's graph it. All right, 2, 2. 2, 2. Cool. Next. What are the size of the steps? Because we know the vertex. So all we need is the steps. And by the way, the size of the steps is the A value. So what are the size of the steps? 1, 3, 5, 7 times 1. So they don't change, right? So that means we're going to go up 1 over 1, 3 over 1, and then 5 over 1, right? 1, 3, 5. And then that's it. And then you got to do the what do you call it? The right side and then the left side. Or you could do the left side first if you like. I think I made a slight mistake here, guys. It's a 16 up here, so just make it a 6. I made a typo. See, I changed that 16 into a 6. Just make it a 6. It'll be easier for the graphing too. By the way, the vertex would also still be 2, 2. And I'll show you on Desmos. There we go. Actually, it wouldn't be 2, 2. It'd be something else because this would be 16 instead. There we go. All right. Oh, so did this particular parabola have any x-intercepts for this one? See, there's none, right? It doesn't. Okay. This is the vertex. And then this is the y-intercept. And axis of symmetry. Of symmetry, right? Got a little messy here. All right. So what's the today? I think I'm gonna just do a couple more of these. I'm not gonna give you anything to do because this is the big thing right here. What's the big thing of today? I mean, they did a review, except that I snuck in something right here. This is the big thing right here, right there. But notice how we graph this really efficiently. Besides plugging in, how many numbers do we have to plug in?
Isn't it just one?
Just one, exactly. And when we were doing it earlier, and I did it on purpose, we were plugging in lots of numbers, right? And then we didn't really know where the vertex was. Okay. All right. All right, let's do another one and ask questions, and then we'll be done when I do one more. Okay, that's it. All right. Now this time, I want you guys to come up with a function, and we're going to turn it. We're going to turn it from factored to standard, even though it makes no sense why we would make something harder, but we are going to do it anyway. All right. Give me a function in factored form. And if you'd like, you can even give me some twins. So you guys decide. All right, just give me some numbers to put in here.
5.
5. Okay. 8. And you say 8?
Yes.
Okay. All right. Let's put okay. You know what? 840. Okay. I'm gonna put a 1/4 out here. Because this will shrink down your guys' numbers. Okay, so this is in factored form, okay? And we can graph this like in 10 seconds. What are the x-intercepts? What numbers can you slide into x to get rid of that 5?
-5.
-5. That's one x-intercept. And what number can you slide into the x to get rid of the -8?
8.
8. So that's your x-intercepts. -5 and 8. All right. What number is smack in the middle of 8 and -5? And the way you can think about it is how far apart are they? Or if you got a quiz and you got a 5, excuse me, you got an 8 on the quiz, and then on the second quiz you got a -5 because your teacher hates you. And what's your average?
3.
Yeah. So it's 3 divided. You took 2 quizzes, so it's half of that, which is 1.5. Does that make sense? So that's where your axis of symmetry is, at 1.5. 1.5 at 1.5. All right. So now we got to plug in 1.5 into that, and I'm going to cheat a little. Okay. I'm going to just do it over here. 0.25, 1.5. Was it -8 or I forgot? +5? Yeah, +5 times 1.5 minus 8. All right, so this is -10.56. So that, and you guys can do like this too, okay? Negative, so that's going to be my vertex. My vertex, I plugged in 1.5. I plugged that in, right? And I got, what was the number? -10.5, give or take. All right, so that's where my vertex is, way down here. 5, 10, somewhere right there. Okay. All right. Question for you. What is the size of the steps? What size are the steps? What size are the steps? They're 1, 3, 5, 7 divided by 4, right? Because times a quarter. So they're going to go up a little bit. They're barely going to go up. They're slight, tiny amount, 3/4, right? And then slowly but surely, they're going to do what? They're going to hit 8. Now, I didn't actually graph these because it's too, they're too small. I can't really graph them very well.
Mr. Kionis.
Yes, sir.
Sorry, I joined late, but I don't know how you got 357 divided by 4.
Oh, gotcha. So the size of the steps of all quadratics is always 1, 3, 5, 7, right? Always, 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 right?
Mm.
Now, except that these numbers might get kind of stretched or shrunk, and they get shrunk by the number in the very beginning, which says, oh, make your steps into quarters. So what's a quarter of 1? So divided by, so if you multiply 1 by a quarter, you get 1/4, right? If you multiply 3 times a quarter, you get 3/4. So basically, I'm doing this in my head. You see that right there? So this is 5/4, right? And then the next one is 7/4. So the steps get shrunken. Let me put that over here so you can see it. Check it out. X here. I got an idea. All right. So see these steps right now on this one? It's up 1/1, up 3/1. Yeah? So the steps are 1, 3, 5, 7, right? 1, 3, 5, 7. Now, if I put a 2 here, now they're stretched. They're actually taller. The steps got bigger. They got double. And if I put a 0.5, now they're up 1/2. Up 1/2, up 1.5 over 1. And if I put a quarter, they get really short. The steps get really short. If I put like 0.1, they're really small steps, tiny little what? Make sense? If I put a negative, well, then they're going to be upside down steps. So the number in the very front is the A value, which kind of messes with your steps. Okay. All right, good question. And explore more of that as we'll explore more of that as we go along. Okay. All right. So we got it. We got the graph. Did we do a lot of math in this one?
No.
No. I mean, pretty much the only math we did was right here, right? And I had to plug it in, and I use a calculator to get 10.5. I wouldn't want to plug in, decimals. All right, so we're almost done with this one, and then we'll be done for today. We are going to transform this into standard form. We're going to convert it like a transformer into standard form. Standard. So you guys know how to multiply this. Does anybody know how to multiply two binomials regarding yesterday's and the day before and then last week's lesson? How do you multiply two binomials? What do you need to draw? So the question is, how do you multiply this? How do you combine that?
Are you talking about like the square thing that we did?
Exactly. Yep. And that's called the area model, because you're turning it into into area, right? Like base times height or whatever area is. You're gonna do x minus 8 here, x, and then plus 5. All right. So now let's go ahead and finish this off. X squared minus 8x, 5x minus 40. And then combine these two right there. And then we got x squared minus 3x, because we combine these two, right? 5 minus 8, and then minus 40. Cool. Don't forget, all multiply by a quarter. Okay. All right. So is this standard form or almost standard form? Remember, standard form has no parentheses. So is it a standard form or is it almost standard form? All right.
I'm confused. What do you mean?
So standard form has no parentheses. And this definitely has parentheses. Right? So how can you get rid of these parentheses? Multiply the quarter into what? Into all of them. Okay. So now you have 1/4 x squared, 3/4 x, and then minus 10, because a quarter of 40 is 10. And now this is standard form. Standard form. Okay. All right, and let me show you on Desmos real quick. Claudia, can you read me the function, the factored one? Is it x minus 5 or plus 8? Was it plus 8 or what was it?
It was x plus 5 and then x minus 8.
Okay, good. All right, so here's plus 5 and then minus 8. And then also read me the standard form. 1/4 x squared, right?
I didn't get to write it down.
Oh, okay, let me just look here. Minus 3/4 minus 10. Minus 3/4 minus 10. Okay, let me do minus 3/4 x and then minus 10. All right, notice how it's the exact same equation. See that? Now, can somebody for 1,300,000 points, can you tell me the vertex form of this one right here? How would I write it? And I'll even show you the vertex. So give me the, how would I write the function for this same graph in vertex form? And to give you a hint, it looks something like this. Something out here, something here, and something here. So tell me what I would replace A, H, and K. And I'll give you the vertex here. Nathan, you have any ideas? Even if you type it in? What would I type? This is the vertex. This is the vertex of this equation.
Yeah.
What would I type? What would I replace A, H, or K with? Okay. Well, what size are the steps?
Looks like quarter.
A quarter. So I would change the A to a quarter. Okay. And what is the X of the vertex?
1.5.
1.5. So in here, in H, I would put negative 1.5, right? The opposite, right?
Yeah.
And what is the Y of the vertex?
Negative 10.563.
There we go. Then I would just leave that the same way, a negative 10.5, what was it? 63? 563, something like that, right? All right, so look, they're all the same equation. They're all exactly the same spot. So today we just kind of explored. I wanted to put it all together for you guys a little bit. Okay? This is going to take like a lot of time, and I will definitely guide you through the whole thing. So I wanted to show you all three of my Robotech, analogy. That it's the same. It's the same person, right? Whether you've seen it in factored form, like the top one, whether you see it in standard form, like the red one here, or you've seen it in vertex form, like the blue one. Okay, they're all the same exact equation. Okay, so which is the easiest one for you to understand? The vertex, standard, or factored? Which is for you? Which is the one? Can you guys? And we're going to be done as soon as you tell me which one for you is easiest.
For me, it's
Yeah.
standard.
Standard, okay.
Probably vertex.
Vertex, yep. And
I like standard.
you like standard, okay. Good. Now, for me, I like to get the vertex and the size of the steps. And then I already know what to do from there. I like to start here and then do my steps, right? And for me, the one that gives me that information is vertex form. Because it gives me the vertex and then it gives me the steps. I'm done. Then the next one I like is factored form because it gives me the x-intercepts first. Then I got to do a little bit of math, right, Anna? And then I get a little bit of math and I'll say, oh, the middle of that is 1.5. And then from there I can do my steps. So this takes me a couple of, more steps, but it's still pretty simple. And then the last one that I still think is not too bad, it's standard form. And because standard form, now I have this cool little formula that tells me where the vertex is right here. Okay. So the if you want to like highlight this in your notes, it'll be the most like important thing. Now this is only in standard form, only because standard form is the only one that has a B. And anyway, so that's our lesson for today. Now,
Can you scroll up so I can see the ones I missed?
yes, yeah. Let's see.
Thank you, Mr. Quinones.
You're welcome.
Bye.
Bye. Post your notes later on. I'll put it.
Bye.
Bye, you
Will
guys.
do.
Okay.
Yep.
All right, Claudia. Where? Tell me where.
That's fine.
Okay. All right. Right there. Bye. Bye, Colin. All right. Let's see. Yeah. So today was kind of like putting it all together, right? In a way. And the best way to do this is to practice a few of them. You start recognizing which is which, right? All right.
Bye, Mr. Quinones.
Bye, Claudia. All right, cool.